It's logical to be concerned about cells dying when you fast. Fasting is a stressful process, and if you were to never eat again, eventually you would expire. However, you can't really die of lack of calories. You'll die of malnutrition long before you could ever die of lack of energy. Your body provides energy in the form of ketones while fasting, and in fact, you have much more total energy available to the body while fasting than when you're in a fed state. This can be vitally important because ketone energy is available even to malfunctioning, insulin-resistant cells that cannot take in glucose and use it as energy properly. This can save the mitochondria in cells, especially in the critically important neurons, which generally don't get access to free fatty acids because the blood-brain barrier blocks them. And this is the main fuel burned in the rest of the body, not glucose, as bro scientists and quacks out there will tell you. It's also important to realize you're born in ketosis, and if you only eat meat, which is the main food that our ancestors ate, you're going to stay in ketosis for your entire life. So don't worry, your brain is totally safe while fasting. In fact, it is one of the best things you can possibly do for the brain. Oh, but I forgot, the guys who follow me around saying cells will die don't care about their neurons. They're just obsessed about losing muscle cells for some reason. And they don't seem to care about little things like your neurons dying.
What an odd little guy.
Not a well-adjusted individual.
Cells like your neurons seldom or even never split in the normal course of things. Other cells, such as your stomach and gut cells, split every few days. This requires protein and can therefore quickly lead to cell death while fasting. While this may sound alarming, it is actually a good thing. If you lose weight through fasting, these cells will die off and this will shrink your stomach. The hunger hormone ghrelin is produced directly inside of these cells in the stomach, and when your stomach shrinks, so does your appetite. Now, everyone has heard of ghrelin by this point, but I don't think I've seen any other channel mention this simple fact. If you shrink that stomach, you get less hungry. When you lose weight by simply reducing calories, going on a diet, you don't get this effect because your insulin doesn't go down and you're not spending long periods without food, so these cells just aren't going to die. In fact, your ghrelin levels go dramatically up when you have a diet for a long period of time. And at the end, you're going to wind up with a stomach around the size that you started, and you're going to be hungrier than ever. You're going to have the same stomach you had before, and you may have lost 100 pounds, but you're still going to want to eat like someone who's 300 plus pounds, just like before. This is part of why it's almost impossible to lose large amounts of weight through dieting and to keep it off. When you fast for periods of 96 hours or less, your appetite goes down and your metabolism stays the same or even goes up. That's because these cells are being killed off over time. So the more often you do fast like this, the lighter your appetite's going to be. So in the long run, you're going to eat less. But when you do these crazy diets, your hunger goes up and up while your metabolism goes down and down. And these diets can take years to lose 100 plus pounds. So there's just no way that someone is going to be able to keep this going and keep that weight off.
Took 12 men and put them onto these so-called semi-starvation diets of 1,400 to 2,100 calories a day. And what was found was that the subjects, they did lose weight, but they constantly complained of being cold. And when you measure their basal metabolism, what you see that there is a very significant decrease, a 30% decrease in their metabolic rate. And that explains why they're cold. The body was shutting down. It was turning down heat production as a way of reducing caloric expenditure. So it turns out that you reduce your energy expenditure so much that if you go back to your regular diet after this period, then what happens is that you start to gain fat. You start to gain weight. And they also measured all these things, including decreases in blood pressure, heart rate, inability to concentrate. All these are manifestations of the body really starting to shut down. A similar study was done by Ansel Keys in 1944, where he took 36 men and put them on a 24-week semi-starvation diet, 1,570 calories a day, and again measured what happened to their metabolism. It turns out that the men's resting metabolic rates declined by 40%. So again, heart volume shrank, heart rate slowed, and the body temperature dropped. There was all kinds of psychological effects. Some people went actually completely crazy. But they were obsessed about food, and there was binge eating and all sorts of problems. So what we see is that one of the key assumptions of the caloric reduction model is actually not true. That is, if you look at caloric intake and caloric expenditure, they are very intimately linked. In fact, if you look at more recent data from the New England Journal of Medicine, a very prominent medical journal from 1995, what they did was they measured something very similar. That is, they took people at an initial weight and they increased their weight by 10% or decreased it by 10%. And what they did then is they looked at what their basal metabolism did. And how they did this was they adjusted their diet, a liquid diet, and they gave them more or they gave them less until they achieved what they wanted in terms of weight. And this is what you found in terms of basal energy expenditure. That is, as you gain weight, your body actually starts to rev up and starts to burn off those calories. And as you lose weight, your body, well, as you return to initial weight, you go back to normal. As you lose weight, your body actually starts to shut it down. So far from being completely independent of each other, it seems that the body has compensatory mechanisms to actually return you to your initial weight. And in fact, these changes happen not only right away, but they actually persist for a surprisingly long amount of time. That is, even a year after your weight loss, so after a 10% weight loss, this is from the American Journal of Clinical Nutrition, after a 10% weight loss 1 year later, what they found was that the total energy expenditure was already down. And it stayed down. So it goes down right away and it stays down. If you look at the hormonal adaptation to weight loss, this is a more recent study in the New England Journal of Medicine, 2011. They took people and gave them very low calorie diets, so 500 calories a day for 10 weeks, and they're able to make them all lose weight. So they wanted to see what happened after they lose weight. Well, after a year, what you can do is you can measure their hormones. So ghrelin, the so-called hunger hormone, is actually, even after a year, significantly higher than where it was before you lost that weight. These ones, peptide YYCCK, they're all satiety hormones. That is, they tell the body that you're full, and you can see that they are lower than it normally would be in response to a standardized meal.
When you fast, this process is avoided due to growth hormone release and lowering insulin. Short fasts are something the body is designed to handle, and it's the only way you can lose weight without consequences to your BMR and your hunger, your basal metabolism, that is. We know this because we've measured it, and the reason it's like that is because in the wild, you're going to be going for long periods without food. And your body is used to that. It's not going to slow you down when it's time to go hunt. It's going to rev up your body. Now, if you go for months without eating or weeks, it's going to slow your metabolism down. But in nature, this would only happen because of some kind of apocalyptic event. Now, the more quickly a cell divides, the more sensitive it's going to be to growth hormone. This is why you can't really get more muscle cells by taking growth hormone, in spite of what bodybuilders think. And it's why you can't increase your brain size in this manner. These are post-mitotic cells that simply cannot divide any further. The only way to get new ones is if they are produced by stem cells. This is a process which is impaired by insulin and therefore mainly only happens while fasting. Fasting also releases BDNF, or brain-derived neurotrophin factor, which creates new brain cells in the hippocampus, which then migrate to the rest of the brain. Cells like the gut and the stomach respond very strongly to growth hormone, and the faster a cell divides, the more it's going to respond to it. And if you're lean or underweight, your body produces much more growth hormone during a fast. This means while your stomach will shrink if you're obese, it's very important to realize that for the elderly or the frail, fasting is actually going to make these organs grow. That means that they're going to have better digestion and they're going to have increased appetite. Surprisingly, a lot of people come to me and say, I just don't have the appetite, that's why I can't fast. Well, fasting in general not only increases lean tissue in people, even the obese, but in people who are underweight, it will increase their appetite. And if you're overweight, it will decrease it. Your body is an amazing creation and it has the perfect system of healing, but if you don't ever fast, it just never engages. In the wintertime, there was no game to be had because the game would be depending on grass, which dies off in the winter. So we would always have periods of starvation and periods of less food. And there's always going to be times when you just are not able to hunt. And that's why your body is designed to work this way, because it knows that you're going to have times when there's going to be no food, and it can use all the energy of your immune system to repair the body instead of fighting off pathogens, which is what it mainly does when you've recently eaten. Another thing that fasting does is kill off negative bacteria such as H. pylori, and that's the main cause of both ulcers and acid reflux. If you can fast for long enough, you can eventually get rid of these problems, especially if you get rid of the processed carbs and lower the carbs as much as possible and increase good fats like butter, fatty fish, and so on. Your body can take care of all of these issues, but you have to actually allow it to do so. While I mainly talk about how to get healthy, cosmetics are important to most people too, and if you lose 100 plus pounds, you won't necessarily look much better. They can even look worse.
I went on the Subway diet, just like Jared. I've lost 180 pounds. I do have a little bit of excess skin though. Bit of a problem here, yeah.
Thankfully, fasting helps here too. Epithelial cells are some of the fastest dividing in the body and therefore die off quickly in a fast. This helps prevent loose skin while losing weight, and if you repeatedly fast, it can also reduce loose skin you already have over time. It's definitely helped me in that respect, though I would not say it's going to have a perfect or instantaneous result. It's definitely much better than looking like you're swimming in a beanbag like some people I've seen. Now, as bro scientists point out to me on a regular basis, you don't have amino acids when you don't eat. That's not wholly true though. While nearly everyone has heard of autophagy by now, most don't realize the main purpose is to scavenge amino acids for use by the body for cell replication. Autophagy removes misfolded and glycated proteins, which mainly come from carbs in the diet, once again, especially fructose, which is very damaging, and also damaged organelles, and byproducts such as degraded retinol that otherwise simply build up in the cell continuously and cause damage over time. Remember, our bodies are designed to fast. We're not supposed to keep eating constantly every day, and if we do, many things simply never get cleaned up in the body. Everything related to autophagy happens within the cell itself, but phagocytes will also become much more active while fasting, and these are immune bodies that are able to go all throughout the body, but when it's highly inflamed, they get kind of stuck in certain areas, or they can't even get into some places at all, such as in a malignant tumor, for example, there just may be no access. But when you fast, this inflammation is dramatically reduced, and this allows them to pass through into areas they'd never be able to get into otherwise. And while it took me a while, this is how I got rid of the annoying neuromas I had on my wrist. This is also part of how fasting helps with the most dreaded of all maladies, cancer. After all, what cells reproduce more quickly than cancer cells? Without a constant supply of amino acids, they can fail while trying to divide and die off. Even simply supplying them with oxygen can spell their doom, as this can allow the mitochondria to signal the cell to enter apoptosis and die. Ketones in the bloodstream can also cause cancer cells to die.
If the mitochondria are defective, they can't use ketone bodies for energy. Only normal cells with normal mitochondria can use the ketone bodies for energy. So when people say cancer cells can burn ketone bodies, no, they can't. Then they would have to argue against all of the structural defects that I just showed you on the structure function in the mitochondria. Mitochondria of cancer cells cannot burn ketones. As a matter of fact, ketones are absolutely toxic to many cancer cells.
What's more, while there are some scaremongers who claim cancer cells can use ketones for fuel, even if that were true, the bloodstream is always full of free fatty acids, and if that were true, the cancer could use that for fuel. But since fat burning requires oxygen, this is simply not an issue for cancer, and if anything, using this oxygen is going to revitalize the mitochondria, and it's going to lead to cell apoptosis for the cancer. And the oxygen can also bind with all of the iron and other resources that the cancer cell hoards, and that can just make the cancer cell explode. In reality, it's glucose that is dangerous, and not because it's used for energy, which, just like their healthy cells, is a red herring. It's because the cancer cells can ferment them into amino acids, and this is called the Warburg effect. The cancer cells can then use these amino acids in order to reproduce. And that's the real danger here, is that you're getting more material for the cell to divide with that is being basically magicked up from nowhere. And in fact, that's where all amino acids come from in the first place, which is done by bacteria. Animals like cows don't really get nutrition from grass, but from the bacteria that ferment it in their four stomachs. And on the whole food train, including humans, this is how these simple essential amino acids come into the food supply in the first place. Now, when you fast, cells go into a protective mode and divide much less rapidly, but in cancer, these mechanisms are turned off. In rodent experiments, rodents subjected to lethal doses of radiation or other injuries survive much more often when fasted for 3 days beforehand. In fact, in one experiment that was lethal to all of the mice that were exposed to radiation without fasting, they all survived if they fasted for 3 days beforehand. This also makes these cells much more resilient to chemotherapy, and that is why cancer researcher Dr. Walter Longo has found that patients who fast or take a fasting mimicking diet for 5 or more days can tolerate several times the dosage of chemotherapy without ill effects. This isn't just psychological, this is your cells being protected on a cellular level. While you might worry this will protect cancer cells have these mechanisms turned off because they inhibit growth. So you really only get benefits from fasting when it comes to cancer. While chemotherapy has many side effects, mainly it affects these fast dividing cells, this causes issues like pain while walking, tendon damage, and constant eye infections that only respond to very expensive antibiotics. It also ruins your gut and leaves you open to autoimmune disease and aggressive, even lethal infections in your bladder. Worst of all, it damages the white blood cells, just like certain safe and defective treatments. And this leads to immunosenescence. Immunosenescence leads to inability of the body to repair the damage of aging or defend itself from pathogens, and that includes fighting cancer. And this is ultimately what kills us in our old age. Fasting during chemo can help prevent all of these issues and even help reverse these problems if you acquired them already. Your doctors won't tell you about these beforehand. They'll rush you into treatment as soon as possible, and only months later, as your body starts falling apart, are you going to realize just how much damage these crazy medications have done. I know that's how it was with my mother, who went through nightmarish problems from her chemo treatments and is still having issues with them. She has overcome most of them now, but when she asked the doctor how long they would last, he told her they'd all be permanent. Thankfully, that hasn't turned out to be the case, and she's one of the quote-unquote lucky ones who miraculously recovered. But I think it's obvious what happened here. It's because she fasted that these problems eventually went away. With just a few 72-hour fasts, she had a dramatic turnaround. I'm sure she'd be doing even better if she fasted more often, but for her, even a small amount was enough to make a dramatic difference in her life. Your body has repair mechanisms to deal with almost any situation. However, these never fully engage unless you fast. Only through fasting can you regenerate your white blood cells, restore your thymus and the cancer-fighting T cells it produces, restore the volume of your internal organs such as your kidneys and your heart and lungs, normalize hunger, reduce ghrelin levels and stomach size in the obese, and increase appetite in the frail, and restore the ability to properly digest food in the elderly. Not to mention overcome the side effects of chemotherapy, prevent or mitigate loose skin, produce new stem cells in the brain and all over the rest of the body, lengthen telomeres in your stem cell pools, or all of the other endless things that fasting can do for the body. And what's more, you can do all of this for free. And if water fasting is too hard, a fasting mimicking diet has most of the same effects. Fasting is definitely not easy, or at least it took years of fasting before it finally became easy in my case. But I can tell you from firsthand experience, it's much easier than trying to lose the same 20 pounds over and over again in the way that fitness scammers tell you to do it. Since the new year is almost here, a great resolution for most people would be to do just one 72 to 96 hour fast in the coming year. That would also be great if you could convince just one friend or family member to do this as well, as it could make a big difference in their lives. Even that small amount of fasting could mean the difference between being healthy the year after next year or developing cancer or type 2 diabetes. And most people could do much more than that, but I'd like to just get everyone doing something. Personally, I do a 36-hour fast every single week just to keep my insulin levels low. And I do a 72 to 96 hour fast every month, and this is where the real healing occurs. And another good resolution would be to watch more videos on fasting, and this is a great way to pass the time while you're fasting, because one of the funniest things about fasting is you can find that you're bored because you're not spending all of your time driving around to fast food places, going to restaurants. It's surprising how much time it can free up in your day. And I've had a lot of people complain to me that they don't know what to do with themselves. Well, it's a great time to watch videos on fasting or to learn about other stuff. And you can do that with my videos too, which happen to be mostly about fasting. Not everyone loves them, but the people who I don't ban all seem to agree that they're pretty good.
I loved it. I'm going to see it again and again.
The critics agree. Frank Rich of the Times says, I loved it. Much better than Cats. I'm going to see it again and again.